Hello, my impressive Algebra 1 students. Let's have another summer adventure together. Today, we will solve systems of equations in two variables. When we have a system of equations, all of equations in the form of ax plus by equals c, they're going to be straight lines. We've been graphing these type of equations. Two such equations are called a system of linear equations. A solution is a system of linear equations in two variables, is an ordered pair, x comma y, that satisfies both equations in the system. There are three possibilities for a system of linear equations. So you're going to have two lines. The two lines will intersect at one point. We'll have one solution, and they're said to be consistent. That's what we're going to be doing today. However, the two lines can be parallel. If the two lines are parallel, they don't intersect any place. So there's no solution, and if there's no solution, they're said to be inconsistent. We can also have where one line is a multiple of the other line. In other words, it's going to be really the same line. And if that's the case, then we have an infinite number of solutions, and the two are called dependent. The two lines are called dependent. And again, we're going to be finding where the two lines intersect where we have one solution. The first way that we're going to solve linear systems by substitution. And the way we started off was we solve either of the equations for one variable in terms of the other. And second, we're going to substitute the expression from step one into the other equation. So we're going to start out and we're going to solve the system of equations by substitution. So this is our system. So we have two equations, two unknowns. Remember, the very first thing we're supposed to do, we're supposed to take one of the equations and solve for 1y or 1x. Well, look, we already have what 1y is. This y is in terms of the other variable. So we're going to take the other equation, which is the x plus 3y equals 8, and we're going to substitute this y into that first equation. See, this y is equal to 2x minus 9. So see where the y is right here? 3 times y, I put 3 times the quantity 2x minus 9. We then are going to use our distributive property. 3 times 2x, 6x. 3 times negative 9, negative 27. We brought down this x, we brought down this 8. So then we have 1x plus 6x, so we have 7x minus 27 equals 8. We're going to undo subtracting 27 by adding 27 to both sides. Negative 27 plus 27 will give us 0. So we have 7x plus 0 equals 35. And then we'll have 7x equals 35. We're going to undo multiplying by 7 by dividing each side by 7. We get x equals 5. This is just x. Remember, when we're solving a system of equations, we have to have an x and a y. So now we're going to have to find the y. And the way that we find the y, we're going to use one of the original equations to solve for y. And I decided to use this equation because it's already saying what y is equal to. So I'm going to substitute the value that we found for x, which was 5. 2 times 5, 10. 10 minus 9 gives us 1, so we have y equals 1. So the solution for this ordered pair, the x comma y, is 5 comma 1. The x we found to be 5, and the y we found to be a 1. Now that was solving the equation by the systems by substitution. We're now going to solve a system of linear equations by addition. This is how we started out. We rewrite both equations in the form of ax plus by equals c. And then, if necessary, we're going to multiply either equation or both equations by an appropriate number. so that the sum of the x coefficients, that's the numbers in front of the x's, or the sum of the y coefficients, the numbers in front of the y's, is 0. The sum has to be 0. And then we're going to add the equations. So we're going to solve this system of equations by addition. So here we have the two equations. You see, 3 plus 6 does not give us 0. Negative 7 plus 5 does not give us 0. So we're going to have to multiply one or both equations by a number such that the numbers in front of the y's equal 0 or the numbers in front of the x's equal 0. I'm going to eliminate the x variables because I noticed that this is a 6 and the opposite of 6 is a negative 6. So I have to multiply this 3 by a negative 2 to get a negative 6, so that when I add them, I'm going to get 0. But here, if I multiply this top equation by a negative 2, I have to multiply all three terms here by a negative 2. I'm just going to bring down the second equation. I'm not going to change it at all. So here, notice I'm having to multiply the negative 2 times the 3x, the negative 2 times the negative 7y, the negative 2 times the 13. And again, I'm leaving the second equation alone. Remember, I'm multiplying the top equation here by negative 2. Then when we multiply, we have the negative 2 times the 3x will give us a negative 6x. The negative 2 times the negative 7y gives us positive 14y. The negative 2 times the 13 gives us a negative 26. I bring down the other equation, and look, you see negative 6 plus 6 equals 0? That's what we wanted. So what has happened, we have eliminated this x variable. So now we have 14y plus 5y equals 19y. Negative 26 plus 7 equals negative 19. We have one equation, one unknown. We're going to undo multiplying by 19 by dividing each side by 19. We're going to get 1y equals negative 1. So what we've done, well, let me see, I want to do this first. What we've done, we now have, that was the wrong one, sorry. We're going to use one of the original equations to solve for x. So I chose this equation. You could use either of the equations, but since I'm doing the problem, I just chose this one. I'm going to substitute for my y a negative 1. Then negative 7 times a negative 1 is a positive 7. I bring down the 3x. I bring down the 13. I undo adding 7 by subtracting 7 from both sides. I get 3x plus 0 equals 6. And that will give us 3x equals 6. We undo multiplying by 3, and we divide each side by 3, and we get x equals 2. Therefore, the solution is the ordered pair x comma y, 2 comma negative 1. So x equals 2 and y equals negative 1. Remember, you can go back to the original equations and plug in this x and this y, and you'll see that they are both solve both equations. They satisfy both equations. And as you are viewing this video, remember you can stop, rewind, review. Stop, rewind, review until you understand what is being shown to you. Thank you for watching this video.